I'm, by the way, Michael Shermer, the director of the Society and the publisher of this, Skeptic Magazine. This is our latest issue with Carl Sagan on the cover and an excerpt from his new book on the 10th anniversary of his death, which is evidence for the afterlife, Frank. See? Sagan is still writing cosmology, so you better watch it when you get there. You and Sagan can have a conversation on the other side. So we're dark for the rest of the summer, and then we'll pick up again in the fall once I get some dates and speakers set up. And our conference will probably be in the spring of '08. We started the lecture series in March of '92 when we had the amazing Randy come and give a full house lecture here in this same room. So this marks the end of our 15th year of the Skeptics Society. So we're kind of excited about that, and if you want to stay up on when the upcoming events are, just go to skeptic.com where we have our upcoming lectures, or just join eSkeptic, which you can do by filling out our little clipboard here. Just put your email address clearly if you're not already on eSkeptic. Just sign that up, and then we'll just pass that around, and we'll record that for you and get you signed up. Or you can just go to skeptic.com and you just hit the send email from your own address, and then it automatically signs you up. It's free. It's a weekly sort of electronic version of Skeptic with reviews and commentaries and op-eds and upcoming events and that sort of thing. And so part of our project this summer is to sort of get caught up with Web 2.0 technology, wiki kind of technology, iPod, podcast, you know, the whole thing, trying to get some more content from our lectures and articles and whatnot up on the web. Our web page is already really quite nice from our new webmeisters, but there's a lot more we can do with the new technologies that are coming up. So that's one of our projects we want to work on. And also note, let's see, here's our man. We have a science celebrity with us. We don't get many of those. Bill Nye, the science guy. Say hi to Bill. Bill, good to see you. Stand up, Bill. Yes, the Science Rules. Yes, speaking of plugs, thank you, Bill. That's good. Yes, we do have Science Rules. We got that from you, actually. That was one of your... Oh, really? Yes. Yeah, I know. Did I mention the royalty checks will come... we'll talk. Have your people call my people in. Yeah. I should note, too, that Christopher Hitchens' book, God Is Not Great, is #1 on the New York Times bestseller list today. Dawkins is just off the list. I think he's 18 or 19 off the top 15. Of course, the list is just, you know, somewhat arbitrary, how far down you go, so you can get that online. We do carry Richard's. We have the exclusive North American rights to his DVD 2-hour documentary, The Root of All Evil, which is a beautifully produced show. He's got another one that he's working on this summer, something along the lines of Assault on Reason, although he's probably not going to call it that now, since somebody else has called it that. In terms of what else we have, let's see. I did want to mention we do have that excerpt from Sagan's book. We actually carry Sagan's book, Varieties of Scientific Experience. And while I was rummaging around in our storage unit, we found some cases of the first edition hardback of my book, How We Believe, which is on the evolutionary origins of religion and why people believe in God. So we're selling those for $10 a piece. Anyway, I'll sign those afterwards. And we will do a signing after the debate. So the format is as follows. Each of our two speakers will have a 30-minute opening statement, and then each will have a 5-minute rebuttal, and then we'll open it up to Q&A unless they want to go back and forth a couple times. But that's probably enough. This is a pretty sharp group. We've got some really good minds in our group here, so I'm sure the Q&A will be quite lively, and we want to allow plenty of time for that. I did want to make a note here. Actually, instead of reading my usual sort of commentary of humor that I pull off the net, the business of science and religion has become quite heated, as you may have noticed, with all these books, pro and con, on the New York Times bestseller list, and articles about the sort of the neocons, the neo-atheists, and so one of the queries we get a lot is, why are atheists becoming so militant, and why is this? And part of it, I do think, Hitchens and Dawkins and so on, Harris in particular, these are post 9/11. I think concerned responses, probably legitimately concerned responses about the extremism of religion, and some of these books go even further, saying that even the moderates are as serious a problem as the extremists, because the moderates enable the extremists to do what they do by endorsing their beliefs. That's essentially the argument. So I wrote a column in my next column in Scientific American, which I will read to you instead of my usual opening commentary. It only takes 5 minutes and 11 seconds, I know, because we're starting to do podcasts on science, scientificamerican.com are doing these little science in 60 seconds and 5-minute type science segments on audio. So we're starting to convert some of my columns to audio. So this column is called Inextricably Bound, and it's subtitled Higher Consciousness Raising for Science and Religion. At 8 straight months on the New York Times bestseller list, Richard Dawkins' The God Delusion represents a genuine cultural phenomenon in which the Oxford evolutionary biologist wants to, quote, raise consciousness to the fact that to be an atheist is a realistic aspiration and a brave and splendid one. You can be an atheist who is happy, balanced, moral, and intellectually fulfilled, close quote. To which I say, amen, brother. Included in this consciousness-raising pantheon are Dan Dennett's Breaking the Spell, Sam Harris's End of Faith, Victor Stanger's God, the Failed Hypothesis, and of course Christopher Hitchens' God is Not Great. Note in his title, on the cover of the book, it's G and a little g, and God is not great. Hardly anybody catches that. He did that intentionally, of course, as Christopher is wont to do. These books and others are tapping into a pent-up frustration with the overly in-your-face evangelism of our culture, an aggravation I often share. Nevertheless, we must be cautious not to let this atheist reward center stroking turn into irrational exuberance. I suggest that we raise our consciousness one step higher. Why? So I have basically five points in this column. 1, anti-something movements are doomed to failure. We cannot simply define ourselves by what we do not believe. I often think of, parenthetically, I only get 700 words, so I have to add some commentary. I mean, it'd be like having the A Bigfootologists or the A ufology. It isn't anything. It doesn't even exist. Atheism doesn't even exist as a thing. We just don't believe. Something like that. So where does that go? As the Austrian economist Ludwig von Mises warned his anti-communist colleagues in the 1950s, quote, an anti-something movement displays a purely negative attitude. It has no chance whatever to succeed. Its passionate diatribes virtually advertise the program they attack. People must fight for something that they want to achieve, not simply reject an evil, however bad it may be. 2, the power of positive assertions. Champion science and reason instead, or in addition, as Charles Darwin suggested. Quote, it appears to me, he wrote this just about a couple months before his death when people were writing him, asking him about his religious attitudes. And he wrote to one correspondent, it appears to me, whether rightly or wrongly, that direct arguments against Christianity and theism produce hardly any effect on the public. And freedom of thought is best promoted by the gradual illumination of men's minds, which follows from the advance of science. It has, therefore, always been my object to avoid writing on religion, and I have confined myself to science. So, for example, the Skeptics Society is a pro-science organization, not an anti-religion organization. 3, rational consciousness raising. If it is our goal to raise the consciousness of as many people as possible to the wonders of science and the power of reason, then we must apply science and reason to our own actions. It is irrational in this sense to take a hostile, demeaning, belittling, and condescending attitude toward religion. By doing so, we virtually guarantee that religious people will, in response, adopt a hostile, demeaning, belittling, or condescending attitude toward science and reason. As Carl Sagan cautioned us in The Demon-Haunted World, you can get into the habit of thought in which you enjoy making fun of all those other people who don't see things as clearly as you do. We have to guard carefully against it. Point number 4, apply the golden rule. Excuse me. In the words of the greatest consciousness raiser of the 20th century, Martin Luther King Jr., in his now canonized I have a dream speech. Quote, in the process of gaining our rightful place, we must not be guilty of wrongful deeds. Let us not seek to satisfy our thirst for freedom by drinking from the cup of bitterness and hatred. We must forever conduct our struggle on the high plane of dignity and discipline. Close quote. By virtue of the golden rule, if we do not want theists to prejudge atheists in a negative light, then atheists must not do unto theists the same. 5, promote freedom of belief and disbelief. A higher moral principle that encompasses both science and religion is the freedom to think, believe, and act as we choose, so long as our thoughts, beliefs, and actions do not infringe on the equal freedom of others. With this principle, we can see why scientists should be tolerant of religion. Not because we want to make nice, because they pay our taxes and we fund it from that or something like that. Or because science fosters open discussion and dissent, although it does, but we can do better than that. But because it is rational to do so. Our freedom to disbelieve is inextricably bound to the freedom of others to believe, as Dr. King noted. Quote, the marvelous new militancy which has engulfed the Negro community must not lead us to a distrust of all white people. For many of our white brothers, as evidenced by their presence here today, have come to realize that their destiny is tied up with our destiny, and they have come to realize that their freedom is inextricably bound to our freedom. And then I close the column with this line, read atheists for Negro and theists for white people, then let freedom ring. Thank you. So to that extent, this is, promising to be a lively debate. We have this very subject at hand, yet we have two world-class scientists to discuss it. I think if we think of this as a dialogue rather than a debate, a conversation about, well, really the greatest issues of our time, of any time. So when I got a copy of Frank's book, we had Frank speak for us back in the late 1990s when his book, The Physics of Immortality, came out. And so when I saw this, The Physics of Christianity, I thought, well, this is gold for the kind of stuff we do, but I can't obviously just put Frank on by himself. We have to have somebody who really knows the science, and that's where we got Lawrence Krauss. So I will introduce both now and then bring up Frank, who will start and go first to present his case for The Physics of Christianity, and then Dr. Krauss will provide his response, and then Frank will have 5 minutes, Lawrence 5 minutes, and then we'll turn it over to you guys. So Frank Tipler is a professor of mathematical physics at Tulane University. I mentioned his book, The Physics of Immortality. All of Frank's books are incredibly interesting reads. Even if I don't always agree with his conclusions, I learn a lot of science and philosophy and theology and physics from them. And his first book, his first big sort of really world-changing book in that sense, was the Anthropic Cosmological Principle. He put that idea on the map. He was the first to do that, along with his co-author Barrow. And so this is sort of an extension of that series of his line of thinking of that. Frank was at the he lives in New Orleans, so he was right there when Hurricane Katrina hit. And as Frank told me, the waters came right up to his front door practically. So it was a close call for Frank, and it was great to spend the day with him. I took him up to Mount Wilson on Friday, and we got to see the 60-inch and the 100-inch telescope and all the cool stuff up there. So it was kind of a fun time to talk about a lot of these subjects in a more casual basis. Lawrence, we've known, he has spoken for us as well here back when his books on the physics of Star Trek. He is sort of hit the popular science scene with those books, but he's written a number of other important books. We have two of them here. Quintessence, The Mystery of Missing Mass is one of them. Dr. Krauss is the Ambrose Swayze Professor of Physics and Professor of Astronomy, and he's Chairman of the Physics Department at Case Western University. You've seen him on, well, you saw him on Bill O'Reilly, right, on Monday? Yes? Always a challenge for a public intellectual. And in fact, yes, indeed. So he's not just in fact, both of these gentlemen are not just academic intellectuals, they're also social activists in that sense, out there not just hiding in the ivory towers, but doing what we all should be doing, participating in the democratic process of getting your voice heard for your position. That's how it works. And so that book, and then we also have is Hiding in the Mirror, about multiple universes and multiple dimensions and string theory and all that great stuff. So those are the books we have. After the debate, we'll set both of them up here at the table, and you can get your book signed. So with that, please help me welcome Dr. Frank Tipler, who will go first. So let's put this on your belts or pockets. Or,
sounds good.
Yeah. Just do it right here. It's good. Right. Good to go. Let me get rid of this for you.
Okay, thank you, Michael. I'm here today to attempt to convert all of you to Christianity. I sort of suspected that would be the reaction from this audience. So first, I'm going to have to convert you all to physics. Specifically, the three great fundamentals of physics, which are quantum mechanics, general relativity, I have to use a technical term here, GL4, the symmetry group of general relativity, and the standard model of particle physics using three-limb symmetry groups. These are the fundamental theories of physics. Together, I won't claim, Lawrence will disagree with me, they form a theory of everything. Once you accept these laws of physics and their full implications, we'll be able to prove that God exists, that God is a Trinity, and we will also be able to understand how the central miracles of Christianity were accomplished. For example, the virgin birth, the incarnation, i.e. Jesus is simultaneously God and man, and also how Jesus rose from the dead. Now, before we begin, it is important to realize that the term miracle, as Christians have always, over their 20 centuries of existence, defined this word, do not involve a violation of physical law. Rather, a miracle is a wonder, something counterintuitive, improbable from the human way of understanding how nature ought to work, which in addition has a religious significance. Now, I'm not, as I said, responsible for this definition. It's originally developed at length by St. Augustine and St. Thomas Aquinas. If you want to read a modern defense of this view of miracle, I can refer you to the book Miracles by C.S. Lewis, and also the work of the theologian who has most influenced me, Wolfhart Pannenberg. Actually, the David Hume and the English deist were responsible for changing this definition. If you read Hume's work, he's mainly aimed at trying to refute Christianity by means of a definition. Now, most physicists, as I've already mentioned, agree that the three theories I have listed, quantum mechanics, general relativity, and the standard model of particle physics, are a starting point for a theory of everything, although practically everybody in physics would disagree that they are a theory of everything. So what I've got to do before I can start defending Christianity and showing you that Christianity is perfectly rational, perfectly scientific, I have to first give you the argument that they are a theory of everything. Quantum gravity, the most difficult problem in physics. In 1964, Richard Feynman at this place quantized a spin-2 field using his path integral method. Now, if one quantizes a spin-2 field, requires it to be a space-time metric, and imposes the full power of the symmetry group of general relativity, Feynman's theory of gravity, quantum gravity, is unique. Now, we know experimentally that gravity is a spin-2 field. The theory of general relativity requires it, of course, and experimentally, which is how I prefer to approach physics, the Hulse-Taylor verification, the Hulse-Taylor pulsar confirmation of the Einstein quadrupole formula proves that gravity is a spin-2 field. GR, of course, tells us that Gravity is a phenomenon, curvature of space-time metric. Observer independence, that is, the physics cannot depend in any way locally on the observer, just gives us this symmetry group of general relativity. Now, interestingly enough, Feynman did not really develop his theory in any detail. Weinberg came along a decade or so later and showed that the Feynman quantum gravity theory is actually renormalizable, which means that the infinities term by term in the Feynman diagrams can be absorbed into constants. So it's no worse than other quantum field theories. But as we know, there are actually two sources of infinity in quantum field theory. The ones that are renormalized away, that I've already referenced, and the ones that generate the divergence of the power series of the S matrix. We also know for 50 years what is the cause of this series divergence. It's a bad choice of the vacuum state. Dyson showed that in a remarkable paper in Physical Review around 1953. David Krauss showed that string perturbation theory also has a series divergence for essentially the same reason. Now, of course, we know that infinities, which is what quantum field theory seems to be generating, do not occur in the lab. But this is the crucial point. Does that mean that infinities cannot occur at all? No. To see this, let us consider the first singularity theorem. Singularity, I should mention, to those who are not technically expert in this area of physics, means something that is intrinsically infinite and therefore cannot be subject to physical law. The existence of such a thing was first proven in a certain mathematical context in Liouville's theorem, proven in 1844. There is, if you go to Wikipedia, look up Liouville's theorem, complex analysis, there is a very neat one-page proof of this particular singularity theorem. It says a non-constant holomorphic, equivalent to analytic function, has to have a singularity somewhere, either at infinity, the boundary of the complex plane in the case of holomorphic functions, or at a finite distance, think qualitatively, the lab. So, we may have a choice, either an infinity in the lab, we know it doesn't occur there, or at the beginning and the end of time. Now, the Hawking-Penrose singularity theorems, which were proven by Hawking and Penrose in the late 1960s, show that from the point of view of classical gravitation, a singularity must begin space-time. Feynman quantum gravity, interestingly, makes a singularity even more inevitable, because the Hawking-Penrose singularity theorems assumed attractive gravity. You don't need that to get the singularities in the Feynman quantum gravity theory, because the sum over histories will get arbitrarily close to infinite curvature, which means the singularity is in there and affecting the multiverse. But these inevitable singularities can actually be used to absorb the lab singularities of quantum field theory, both the renormalizable ones and the series divergent ones, by the same mechanism. Now, that quantum gravity is relevant to quantum field theory infinity problem is fairly easy to see qualitatively. Consider a self-energy loop. Now, what gives us in the reason we have to renormalize away certain infinities, and when we evaluate certain integrals, the energy is going to infinity. The energy in the Feynman diagram is restricted to a smaller and smaller region. You think about this, if it goes to a smaller and smaller region, higher and higher energies, necessarily you're going to end up with a black hole, which would then evaporate via the Hawking process, and as Hawking showed before he retracted, violating unitarity. His original calculations, in my judgment, were correct. I went through them. Imposing unitarity, therefore, gives a relativistically invariant cutoff, term by term, and this cutoff depends on the order in the power series, giving a convergent series. The same mechanism we can use to stabilize the Standard Model. We all know there are tendencies of the Standard Model to disintegrate if it's not controlled. And also, this theory will predict that there will be an increase in the constants of nature, for example, the fine structure constant alpha with cosmic time. You might want to understand this qualitatively, because as we know from the energy-time uncertainty relation of quantum mechanics, if you are very precise on your measurement of the energy, you get very imprecise in the time interval. Energy and time are interconnected. So we also know that the fine structure constant actually depends upon the energy at which it is measured. So if it depends on the energy, it is plausible, this is not intended to be a rigorous argument, but plausible that it can depend on cosmic time, and a more detailed analysis of this theory shows that it does. And in fact, we get a prediction of how rapidly the fine structure constant should increase. It should increase about an order of magnitude lower than the current experimental lower bound, so that should be accessible to experiment to test this in the near future. Now, this particular mechanism to stabilize quantum field theory only works if there is a final and an initial singularity, and in fact no event horizons, which automatically solves, incidentally, in passing, the black hole information problem. How does the information get out of the black hole? There are no event horizons, so the black hole is never, strictly speaking, there. Black holes exist only as astrophysical black holes, not as the objects which are defined by event horizons. Now, no event horizons are possible only if the universe is spatially closed. You can improve this argument, not only get spatial closure, but actually the three-sphere topology. And furthermore, the final singularity is a single point, end of time omega point, in the Penrose C-boundary construction. This, in effect, picks out a global vacuum state, which, in effect, must define a classical universe now. This means, in turn, the wave function of the universe, everything including the universe, has to obey quantum mechanics, so it has a wave function. Must have initially been a delta function, which incidentally explains the spatial flatness which we observe. It's just not any forces that we haven't seen, like the inflation field. It's just quantum kinematics, a result of wave packet spreading, and everyone is familiar with versions of this wave packet spreading. You've been familiar with it in the case of sound waves. Whenever you hear someone speak around a building without seeing the person, that's just wave diffraction. Now, quantum field theory in the form of the Bekenstein bound in such a universe then forces initial case of the universe to be homogeneous and isotropic. And furthermore, it picks out a unique field of the standard model, technically an SU2 left field, that initially gives, nicely gives the observed excess of matter over antimatter, whereas with the usual boundary condition, inconsistent with quantum field theory, which is why I reject it, gives, as we know, a baryon generating mechanism that produces way too much photons per baryons. Also, the perturbation spectrum is necessarily scale invariant since the universe is necessarily flat. Basically, Harrison showed that long before inflation was even thought of. Now, the universe, in other words, necessarily looks like this. Here I've drawn, in this picture, two universes which start in an initial singularity, expand out to a maximum size. Remember, this is a closed universe, and goes back into a final singularity. So, what we actually have here is a three-entity, technical term is hypostasis, a three-hypostasis structure to the singularity. An initial singularity, what I will call an all-present singularity, since it exists at each time for each universe in the multiverse, and then a final singularity. All right, now, there are three hypostases, in other words, to the cosmological singularity. Physically, the initial singularity, here we're making our connection with theology, is the uncaused first cause. Causes are things which we observe inside of space and time, governing matter inside of space and time. The physics tells us that the initial singularity is the initial cause of everything, but it itself, we can see from the physics, does not have a cause. It is not itself subject to physical law. It is not itself in space and time. It is transcendent to space and time. Similarly, the final singularity is the uncaused final cause, and we can think of the second hypostasis as the uncaused sustaining cause. Work out the quantum field theory, seeing how the quantum mechanics works throughout the multiverse. That's a nice way of defining the second hypostasis. Now, let's remember medieval theologians, Maimonides and St. Thomas Aquinas, they defined God, what does this word God mean, to be all three of these. The 5 ways proof of St. Thomas Aquinas, for example, gives an uncaused first cause as its conclusion. So given the definition that these great theologians have given for the word God, we are forced to conclude, A, that God exists, it's triune, i.e. is a trinity, and furthermore is the cosmological singularity. Now, in deducing the existence of the cosmological singularity, otherwise known as the triune God, I've assumed that the validity of Feynman-Weinberg quantum gravity and the Standard Model. Now, all experiments are consistent with these theories, and as a scientist, I always emphasize experimental proof or disproof of theories, so I will believe the fundamental theories until I have an experiment showing them to be incorrect. This is the rational approach which I take and which Christians have always taken. Now, with the appropriate cosmological boundary conditions, they are also mathematically consistent. The Feynman-Weinberg quantum gravity theory is the unique natural quantization of general relativity. It's the only way to quantize general relativity is we're going to start with a spin-2 field and require the spin-2 field to actually be a space-time metric and require the full GR4L, the full symmetry group of general relativity. Just as general relativity itself is the unique natural specialization, not generalization, but specialization of Newtonian gravity, which is not generally known, but nevertheless is true, is also curvature. Newtonian gravity is curvature, just like general relativity, as the great French mathematician Élie Cartan showed in the early 20th century. Similarly, quantum mechanics is the unique mathematically consistent specialization of classical mechanics, classical Newtonian mechanics, in its many-world formulation, often called Hamilton-Jacobi or HJ theory. For these reasons, that we've got a series of specializations of theories rather than generalizations of theories, we can be confident that quantum mechanics and general relativity and their natural join are consistent. We have, in other words, had a theory of everything for 30 years, though very few, including, for example, Feynman and Weinberg themselves, actually believe it. Well, I can't help that. Aristarchus of Samos solved the problem of the solar system in 200 BC. He constructed the heliocentric model, later reinvented by Copernicus, though very few at the time, and I can argue that probably not even Aristarchus actually believed it. Someone should have. Okay, now in my physics journal papers, I use a mathematical technique called Cauchy completion to define the 3 hypostases. In my book, The Physics of Christianity, I describe and outline how Cauchy completion works as a matter of mathematics, but Christianity, of course, is asserting something quite different, namely that the 3 hypostases are defined by persons. God is a trinity of 3 persons, one God, but 3 persons. So let's see how this can work with regard, in one case, to the second person. Now, what I've drawn here is a picture of the multiverse. I've already outlined how the multiverse works. It's a collection of universes joined together by quantum mechanics. Quantum mechanics is intrinsically a multiverse theory, just as classical mechanics is in its most general form. Now, we have, if quantum mechanics is correct, if classical mechanics is correct, analogs of ourselves in parallel universes across the universe. However, ordinary human beings, we have people just like ourselves out there in these other universes, people identical to you, listening to people identical to individuals identical to me, giving this identical lecture across the universe. However, if you go across the multiverse, we will find out that ordinary human beings, you and me, can only exist in a relatively limited region in the multiverse, entirely away from any of the hypostases of the singularity. However, it is possible to imagine that an individual, Jesus of Nazareth, say, in the multiverse, his equivalence class goes all the way into the singularity. Now, what you can do is develop this in detail and show, using quantum mechanics, that although we are not aware of our analogs of ourselves in the other universes of the multiverse, quantum mechanics tells us why. Quantum mechanics says it is possible for a mind to exist that would be aware of the other analogs of themselves, in which case the Jesus that appeared in our version of in our universe of the multiverse would be aware of what is happening here at the singularity itself. He would be the singularity. So we've got a nice little physical theory for how the incarnation could actually work. Now, this Sunday is actually, in the Catholic Church, the solemnity of the Most Holy Trinity. So it is appropriate that I have begun with a proof from physics of the existence of God, the fact that God consists of a Trinity, and that Jesus is being both God and man, and that it makes perfect sense from the multiverse point of view. Now let's go on to the second miracle, central miracle of Christianity, the virgin birth. Now, in my book, I describe in some detail how it's very easy to use modern DNA technology to test a woman's claim, which has been made in the past. We can certainly find references in the historical literature. Finds herself pregnant, claims, I didn't know a man. Is it possible she is telling the truth? Now, this particular DNA test, in my book I give plenty of references to these particular DNA tests, showing that many vertebrates actually can have virgin birth. We simply do not know about primates, or for that matter, human beings. But given that we've got 6 billion human beings on this planet, and there are plenty of women out there making the claim, I didn't have sex with a man, we can now test this and find out how common, if at all, virgin birth is in human beings. Judging that over the past few centuries, the complexity of the animals, which are now known to have virgin birth, is increasing with time. I would be surprised if primates, in particular human beings, do not give a virgin birth occasionally, but I, as a scientist, want experimental data for this, so I will encourage you, if you know such a woman, to challenge her to prove this claim using the DNA test. As I say, I want data. Here's a nice way to do it. That's why I'm glad to have the opportunity here to make the general suggestion we need to test this thing. I actually knew such a woman myself personally. She wouldn't give me the DNA, alas. Maybe you'll have better luck. Okay. We need data, though. Now, Jesus' virgin birth provides a special problem, and I'm sure you all know, since in a virgin birth, that's why you test this, all genes in the child must be in the mother, and we know that Jesus was a male. Now, normally, human males are, of course, as we all know, XY, and the Y chromosome does not exist, needless to say, in the female. But actually, 1 in 20,000 human beings we actually know are XX males. What happens is the genes generating sex are actually not in either the X or Y chromosome. What they are located in the other chromosomes, which are then activated by the presence of 2 X's or an XY. What you need is a gene in the Y, in the X, which would be coding for instructions to turn on the male genes, but turned off by the standard DNA mechanisms turned off in the Mother Mary and then activated in the fetus, which later became Jesus. Now, I propose, therefore, that Jesus was an extreme, i.e. above average in height, etc., double X male, and I point out in my book that the only DNA test which has actually been conducted on the Turin Shroud and the Oviedo cloth are consistent with XX maleness. Everyone in here, I'm sure, is familiar with the Turin Shroud. The Oviedo cloth is claimed to be the face cloth described in the Gospel according to John, which also was in the tomb. Also, therefore, it was covered with Jesus' blood, just like the Turin Shroud was, if both of these are genuine. As I say, the DNA is consistent, the blood on these two samples, with double X maleness. And I also show in my book why the carbon dating is rather doubtful. The main reason is we now think that they took the samples from a more recent repair, medieval repair of the Turin Shroud, for example. Now, let's go on to Jesus' resurrection. Description of Jesus' post-resurrection spiritual body showed that he had the ability, I'm going to assume, since we've got so much of Christianity, these descriptions are correct, and see if they're possible. Assuming they're possible, then, assuming they're true, then he had the ability to materialize and dematerialize at will, vanishing and reappearing to his disciples. That's the description. Is this physically possible? Actually, it is. A physical mechanism is provided by the baryon creation and annihilation process that I mentioned earlier in this, I'm afraid, very technical talk, provided by the Standard Model. We know this mechanism works. For example, one thing we can imagine, you annihilate baryon and lepton number, but B minus L is conserved. So what we can have is the following process. We can have proton plus electron goes to a large number of N neutrino-antineutrino pairs with N sufficiently large. What we would see is Jesus would just disappear with no other effect. And reversing the process will then give materialization. And I'll let Lawrence tell you how improbable this is by standard process. But I'm going to argue a little bit later on that if the laws of physics are to be globally consistent, this had to occur. I.e., there is forced not by human ways of measuring probability, but by the laws of physics themselves, so the probability is necessarily 1. Gigantically improbable, however, by human ways of calculating probability, leaving out these additional physical factors. Now, since this is Caltech, a school devoted to advancing technology, I saw a T-shirt, Science Rules. I approve the approach, namely we should use rationality and physics to understand the physical world and also to advance technology. So let me point out that this total conversion of matter into energy is allowed by the Standard Model of particle physics, which has survived every experiment we've been able to throw at it. Now, with sufficient cleverness, we should be able to harness this process to provide a new source of energy, and if we can adjust it so that the output is not electromagnetic radiation but neutrinos, create the perfect rocket. Christianity's contribution to this is only to suggest that it should be within reach of our technology. Now, the reason ultimately that this process should be accessible is, and it must be begun to be utilized in the near future, so the acceleration of the universe can be counseled. Now, one of Lawrence's contributions to physics is to provide the evidence that, in fact, this acceleration was actually occurring. But if the acceleration were to continue indefinitely, then the final singularity would not exist, and this mechanism for stabilizing quantum field theory will not work, and furthermore, by Hawking's arguments, unitarity would be violated. So I can conclude that it must collapse so that unitarity will be preserved. Now, if the Standard Model is true, and as I said, there are no experiments showing that it's not, and we've tried to refute it by throwing experiments at it, there is only one source for the acceleration, for the quintessence, and it's the standard model. Cosmological constant, which is there in the fundamental physics, fundamental Lagrangian technical term, required to counsel the large negative Higgs potential near its minimum. But, this is the interesting thing, a super energy source that I have just described, if technically feasible, will also yield, if we decide to release it in forms of electromagnetic energy, bombs that are to nukes as nuclear weapons are to spitballs. Not a nice thing to have around. Now, since the standard model matter annihilation process that I have described would be achieved, roughly speaking, I outline how in principle we might do it in my book, by a quantum tunneling mechanism, I would expect us to develop this particular process about the same time that we develop quantum computers, which of course, as people here know, since this is one of the centers for research in quantum computation, requires maintaining quantum coherence on a large scale for a considerable length of time. Also, once you have a quantum computer with hundreds of elements, for example, you then have easy ability to reach human-level artificial intelligence and, of course, human downloads. Now, the people who are interested in developing computer technology have predicted that human-level artificial intelligence and human downloads should be here in 50 years. Computer artificial intelligence enthusiasts call the arrival of the human downloads and human level and beyond artificial intelligence the singularity. Now, this terminology is actually more apt than they realize. We are told by Jesus in the Gospels that just before he returns, we can expect a great tribulation. So bad that were he not to intervene directly, no human would survive. Super bombs possessed by artificial intelligences and human terrorists would seem to fit the bill nicely. So, we can expect the second coming, the direct intervention of the second person of the cosmological singularity within 50 years. Summary. We have a theory of everything. Automatic from the physics, Michael, and my audience. Which physics? Well, we have a theory of everything. Lawrence will tell you why he doesn't believe it. But nevertheless, we do. It was created, not by me, but by other great scientists. They're Feynman, Weinberg, quantum gravity, and the standard model. Now, these yield the cosmological singularity, which is the uncaused first cause. It exists and is, by definition by St. Thomas Aquinas, God, who is triune. The incarnation of Jesus, being both God and man, makes perfect sense from the multiverse point of view. The virgin birth is a natural process that's been argued by the first great Christian theologian Origen and continued by St. Augustine. All I can do here is give you the mechanisms of how it could have actually have been a natural process, and it's a natural process like all miracles. The resurrection is a standard model process. I described in outline how it occurred. And finally, the second coming, the singularity, Jesus coming back again, we can expect within 50 years. Thank you.
I got to take the mic there. Good job. But we have to switch the mic. And while you're doing that, you can go around that. Wow, Frank, that was really incredible. You packed it in there. Good job. Perfect 30 minutes.
Was it 30? I thought it was
35. You can take your 35 if you want. Frank, I couldn't help but picture Mary standing there before the tribunal saying, "I did not have sexual relations with that man, Mr. Joseph."
For Joseph. And it was only when
No, I have my laser pointer.
dream that Joseph was persuaded otherwise. So it's a pity that Mary did not have that.
Well, it really depends on what the meaning of is, but in any case, Well, this is not a week I've been looking forward to. It began in Kentucky on Monday, and then the O'Reilly show, and now this. The reason I was looking forward to is Frank Tipler is a delightful, charming man who I know, and I hate to do what I'm about to do. Okay, so the title of my talk is Mr. Tipler versus Reality. And I'm going to spend a little time talking about why I think it's complete nonsense. And then I'm going to actually try and actually explain something as well, because I think I spend too much time countering nonsense. And anyway, this is a wonderful statement about science and philosophy. It's really well written, I think. When any scientist rejects the implications of physical law for any reason other than experiment, he ceases to be a scientist. He becomes a philosopher, practicing a discipline in which he has no special expertise. When he rejects the implications of physical law without experimental warrant, he is no longer speaking as a scientist, he's speaking as a layman with no more authority than the average person on the street. Fortunately, when a scientist leaves the discipline in which his expertise rests for philosophy, he generally retains his scientific habits of honesty. If pressed, he will tell you that he's no longer speaking as a scientist, but as a philosopher. Just ask him what the experimental evidence for his claim is for his claim, any claim, he will generally tell you there's none. Okay, the author of that is Frank Tipler. And in fact, in the Physics of Christianity. And I think we should remember that, and what we just heard, because in fact, there is no evidence for any of these claims, as I'll point out. And in fact, Frank, unfortunately, has ceased being a scientist and become a philosopher. I want to give you the short version of this, and I don't want to pull any punches because I've written a review of Frank's book, which Frank's probably read. So I want to just make this quote from that, because unfortunately it's what I believe. As a collection of half-truths and exaggerations, I am tempted to describe Tipler's new book as nonsense. But that would be unfair to the concept of nonsense. It is far more dangerous than mere nonsense because Tipler's reasonable descriptions of various aspects of modern physics, combined with his respectable research pedigree, give the persuasive illusion that he is describing what the laws of physics imply. He is not. This book provides an object lesson in the dangers of pushing science beyond its domain of validity and using scientific approximations as if they are completely valid in all contexts. So let me, that's me, okay. So let me just outline some of Frank's claims in a way that may be more intelligible than some of the ways he just described. The standard model of particle physics is complete and exact. We have a clear and consistent theory of quantum gravity. The universe must recollapse. We understand the nature of dark energy. We know why there is more matter than antimatter in the universe. Okay. First, it isn't. Secondly, we don't. Thirdly, it doesn't have to, and all the evidence thus far suggests the universe will not recollapse. We certainly don't understand the nature of dark energies, and we don't understand why there's more matter than antimatter in the universe. We simply do not understand any of those key features. We do not have theories that accurately describe them, and pushing the theories we have beyond their domain of validity to make claims for whatever philosophical inclination you have, whether you believe in God or don't, is equally fallacious, in my opinion. Now, I want to just focus on two things that are just manifestly wrong in what Frank has said, and then I'll move on. Because, I mean, I could spend a long time talking about all of them, but I think I want to just point out 2 points. So, Frank talked about the resurrection, this baryon decay into neutrinos and antineutrinos. This is the most technical I'm going to get. I'm going to try and blind you with science, just one slide, but really, otherwise I want to try and be understandable. There's a process in physics called vacuum tunneling. It's really weird. It's really kind of neat about quantum mechanics. If I throw a baseball against this wall, it bounces back, and it keeps bouncing back. If I throw it really hard, I might break a hole in the wall and it might go through. But the neat thing about quantum mechanics is if I throw an electron at the wall, it can do several things at the same time, but in particular it can bounce back, and it can actually sometimes end up on the other side of the wall without ever having gone through. It's remarkable. Electrons do that, elementary particles do that, and nuclei is responsible for radioactive decay. They can actually tunnel through barriers, disappearing at one end and appearing in the other end, and it happens. Just a fact of life. Okay? So that's interesting. Now, there was the process is normally extremely small. One of the reasons why some radioactive elements live billions and billions of years. In the 1970s, a guy named Gerard 't Hooft, who won the Nobel Prize later, showed that in the standard model, the model of particle physics that Frank's been alluding to, there's a tunneling probability that actually normal matter will decay. And it's this configuration is called an instanton. It leads to an interaction I couldn't resist, although it's completely irrelevant to put it down. But I want to show you you've written it down, okay? Doesn't matter. Actually, there's one thing here that matters. It's an exponential. Because these things are normally exponentially small. So I want to just give you the numbers. So that was the interaction. And probabilities of quantum mechanics go like the square of your interaction. So there was a factor there, e to the minus 4 pi, 2 pi over alpha. You square it, it's e to the minus 4 pi over alpha. Alpha is the strength of the electroweak theory. If you plug it in, the probability for that decay goes like, ignoring other factors which also make the number smaller than this, 10 to the minus 140. That's the probability for this happening. Now, this leads for the possibility of a process for proton decay into particles like neutrinos, as Frank said. The rate is about 10 to the 140 times the characteristic lifetime of unstable particles with the mass of the proton. That works out to be 10 to the 116 seconds. That's 10 to the 109 years, which is approximately 100 orders of magnitude larger than the current age of the universe. But it's worse. Now, Professor Tipler argues that Jesus' resurrection occurred as his body disintegrated into neutrino-antineutrino pairs by this mechanism. Okay, let's calculate that probability. The probability that let's say he was a light person, 10 to the 27 atoms, probably 10 to the 29 is a better number, but I want to give Frank all the benefit I can give him. In a body will decay by its process in 1 second. If you work out that the probability that it will decay in any given second is 10 to the minus 143. There are approximately 10 to the 80 protons in the entire observable universe. Therefore, the probability that any proton in the universe, not just the one in Jesus' body, but any proton in the universe, will decay by this mechanism in the entire history of the observable universe, 10 to 14 billion years, is 10 to the minus 29. That's a decimal point, 29 zeros a 1. Okay? That's the probability that any proton in 14 billion years will undergo this mechanism. Now, you might say that's rare. Now, interestingly enough, Professor Tipler wrote a book on the anthropic principle, and this is one of the most perverse uses of the anthropic principle I know of, in a sense. Because how can he reconcile these two facts? Simply, he says, while the probability of this happening is effectively 0, although he doesn't get it small enough, it turns out he says, well, okay, I can convolve that probability with another probability. He says, our universe wouldn't exist if Jesus wasn't here. Therefore, when I combine that effectively almost 0 probability with that other probability, multiply the probability that our universe would exist if Jesus wasn't here, which is smaller, you multiply the likelihood that this happens by the probability of having a universe where this happens, you come up with the probability of order 1. Get it? Okay, you take a probability that's really rare, but you say, well, it's really rare, but unless it happened, then we wouldn't be here. Therefore, it happened. Okay, that's an interesting use of a claim that you take the universe based on experiment. The universe based on experiment tells us this will never happen. But actually, it's worse than this. I would argue that this is a rationalization and certainly not an explanation. You find that the one thing you know happens, and you find out it's never going to happen, and then you say it must happen. Okay? Now, it's actually worse because Frank gets the physics wrong. In particular, a few important items that I want to point out as a particle physicist. He assumes the process can occur at a rate that is unsuppressed by this exponential factor if the energy is high enough, and in one of these multiple universes that he talks about, he assumes that all of the energy is high enough. But it can't be. In fact, it doesn't happen at an unsuppressed rate at high energy. That's a misconception that some people have. It can only happen at high temperature. So at high temperature, if you heated up the universe hot enough, this process would happen. So you have to ask what's the temperature? Turns out you have to heat the universe up to 1,000,000 billion degrees, okay, before it happens at an unsuppressed rate. He's argued this so that, he pointed out that this would happen in the region where Jesus was resurrected. You could bring up this energy and make it happen. But in fact, you can't bring up the energy. You have to heat up the whole region to 100 million billion degrees, which I suspect would be bad for the Shroud of Turin. Now, he points out that in order that nearby individuals are not killed by radiation, he requires that, in fact, in each one of these decay processes, a million neutrino-antineutrino pairs are produced in each proton decay. However, in fact, the 't Hooft-Lagrangian tells you what the number is, and it's 6. Okay, it's a slight difference. Okay, so and that was he determined this so that the nearby individuals wouldn't be killed by radiation poisoning by the neutrino-antineutrino pairs. So the physics is just wrong. Just for fun, I contacted a friend of mine, and he got this quote: "The standard model is not exact, and instantons do not provide a plausible mechanism for the instantaneous decay of all nucleons in a human body. These scientific explanations are less flattering to the Christians than Tipler's, but the flattery index is even worse than the citation index for judging the quality of a theory." That comes, by the way, from Gerhard 't Hooft, who developed the mechanism I contacted by email. Okay? Now, that's one thing that Frank gets wrong. The other is this divine singularity stuff. So, Frank has argued that general relativity is exact and sensible as a quantum theory. The claimed evidence is work by Richard Feynman and Steven Weinberg, as he's pointed out. Not explained, but pointed out. And he argues that two singularities must exist, one at the beginning of time and one at the end. Okay, and he tries to argue that there's this trinity and that, et cetera, et cetera. Now, the point is that itself, that claim about quantum gravity is just wrong. And here's a quote. Well, I might as well put on the author who I contacted, Steven Weinberg. At first, I had no idea what he meant in quoting me, but I then realized that he must mean, that in fact I knew this, that I'd shown that quantum gravity is perfectly normalizable. So that's what Frank talks about. If you include all possible terms in the action consistent with symmetries, including arbitrary powers of curvature and arbitrary numbers of covariant derivatives, none of that means anything to you. But the second statement is important. Although we're normalizable, it's an infinite number of terms here, such a theory loses all predictive power at sufficiently high energy, so it is not a complete theory. It is certainly not general relativity. It doesn't resemble general relativity at all, though it reproduces the successes of general relativity at large scales, but nowhere near a singularity. In particular, it could tell us nothing about the singularities because that is precisely where it loses its predictive power. This supposed theory of everything is precisely a theory of nothing, just where Frank wants to use it. Okay, it's just... So two central tenets of this, the physics of this is not existent. Okay? Now, I could go on, but I think my point is made. And what I want to do, since I told you guitar talking nonsense, I want to, the last thing Frank talks about is that the need for a final singularity. And I just want to point out to you that all of the evidence, if you actually care about evidence in nature, in the real world, is that the universe is going to expand forever. Now, we don't know that for certain. In fact, I'll point that out. One of the things I've proved is that you don't know for certain. So I want to spend, I couldn't resist. I want to give a little physics lecture that actually explains something. And so let me begin with Einstein's equations, okay? And there's a very divergent group in this audience, so I wanted to write them in a user-friendly form. Okay, so, yeah, everyone understand this? The lawyers understand this? Okay. It's not completely facetious to do it this way, but nevertheless, I mean, the left-hand side gives us everything that's related to geometry. The right-hand side gives us everything that's related to energy and momentum. In fact, that's what makes this equation so interesting. The energy and momentum of stuff produces curvature in the universe, which affects the motion of the energy and momentum, and that feeds back, and that feedback causes general relativity to be quite interesting. And Professor Tipler's done interesting work in this, in fact. I couldn't resist writing the letters, but that doesn't matter. So Einstein, when he developed this equation, realized it had a problem. It didn't describe the universe that we lived in. Nowadays, that doesn't bother many physicists when they do that, but it used to. And Einstein, the real reason it didn't explain the universe he lived in is in 1916, the universe was static and eternal. And general relativity has the same problem that Newtonian gravity has. It sucks. it always pulls, it never pushes. And you can't put mass points out in a fixed spot without having them collapse together. So you couldn't have a static eternal universe, and Einstein knew it, and it was a problem. And I'll get to the philosophical implications of some of this later, the religious ones perhaps later. But Einstein was a bright guy, and he realized, consistent with the symmetries that had led him to develop this, he could add an extra term to his equation. That term there. He called it the cosmological term. And what it would produce is a repulsive force throughout empty space. Everywhere. And why did he want that? Because he said, well, maybe if there's this really small repulsive force that we can't measure here on Earth because there's so much mass, but out in empty space it's there, it'd build up and it would hold apart all the distant stars and galaxies and stop them from collapsing together. And maybe explain this static universe. Now, it turns out to have been wrong. Even the mathematics of it wasn't quite right. And Einstein later on called it his biggest blunder. Why? Because this guy here, among other places, one of my great heroes, Edwin Hubble, he's a great hero of mine because he reminds me that there's hope for humanity. Because he began life as a lawyer and became an astronomer. And he discovered the universe was expanding. Okay, and these are not sperm; these are galaxies, and he discovered that when we look out, in fact, we look out at a telescope not too far away from here, that in fact galaxies are moving away from us, and those that are twice as far away are moving twice as fast. And if I had more time for a physics lecture, I'd explain this, why this unambiguously tells us that the universe is uniformly expanding, but it does. And it was 1929, and this is his data. I thought I'd show you the data. From 1929. This is velocity, and this is distance. And this is one of the reasons he was such a great scientist, because he knew to draw a straight line through that data set, which is not so obvious. But he also did us a great favor, us astrophysicists. He got the answer wrong by a factor of 10, and we've tried to emulate that ever since. He got it wrong by a factor of 10, not because he wasn't very good, but if you're going to measure velocity as a function of distance, you have to know how to measure velocity and distance. And those are hard to measure. Velocity turns out to be easy to measure, and I forget if I have a transparency. If I do, I'll show it in a second. Turns out to be easier to measure by using something called the Doppler effect, and I had a cartoon about that, but I don't think I'm going to show that. The hard part is to measure distance to distant objects. How can you measure how far away an object is? We don't have tape measures that go out millions of miles. We can't use geometry like, when I was growing up before lasers. Surveyors would measure the distance to the back of the room by pointing, taking a line and measuring an angle here and moving a known distance over here and measuring another angle and using plane geometry. That only works for the nearest stars. So we have to use what's called a standard candle. We have to look at an object like I could at the back of the room. If I turned out all the lights except for one light bulb, and there was a 100-watt light bulb, and if I had an old-fashioned camera, the young people won't remember this, but they used to have light meters. And so if I had a 100-watt light bulb and a light meter here, and I saw there was 1 watt of light coming to my camera, and I know how the light spreads out, I can work backwards and figure out how far away the light bulb is. The universe isn't populated by 100-watt light bulbs, so we have to look at the equivalent. We have to find the equivalent. Something whose intrinsic brightness we know, and we then look at how bright it appears, and we determine its distance. We have such objects now, we believe. These are remarkable objects. This is one of my favorite Hubble Space Telescope pictures of a distant galaxy long, long ago, far, far away. And and you see the star here, which is as bright as the center of this whole galaxy, which would tell you, you would believe that this star is actually nearby. It's intervening. It's a nearby star. It's not true. It's a star at the edge of that galaxy. And yet it's as bright as the entire center of the galaxy, which is 10 billion stars. How can that be? That star has just exploded. And it's a very particular type of supernova, a exploding star, called the Type 1a supernova. And these are, of course, among the biggest fireworks in the universe. We can see them across the universe, and they turn out to be beautiful standard candles. Here's a movie of one in a distant galaxy. You can see. We can actually measure it, and we can also measure its colors, which tell us what type of supernova it is. I'll take a digression for 1 second. I think I have a little time. Fortunately for us, supernovae don't happen very often. Fortunately for us, they happen. I wrote a whole book about it. If they didn't happen, we wouldn't be here, because all the elements in our body were produced in them. But but they happen about once per 100 years per galaxy. I just want to point this out because it demonstrates one remarkable aspect about the real universe, not the invented universe, the real universe. 100 years, once per 100 years per galaxy. How can we study these things? Well, we could assign a graduate student to each galaxy. That would work. But 100 years is about the right time. But no, but we don't have to because the universe is big and old, and rare things happen all the time. And so, if you take your hand and hold it out arm's length and you put a little dime-sized hole and you point it at a dark spot in the sky, if you had a powerful enough telescope, you could see about 100,000 galaxies in that little spot. And that means, think about it, once per 100 years per galaxy, 100,000 galaxies in a given night, you see 10 stars explode. And astronomers actually do that. They do telescope time and they say, tonight we're going to see 10 stars explode. And they might see 9, they might see 11, it might be cloudy. But we use that, and we've been able to use these things, and unfortunately I don't have time to give you an adequate explanation of why, I think I'll skip this, of why it's a standard candle. But it's allowed us to measure the expansion rate of the universe very well. You have a straight line. Of course, this was made after the great discovery that on a log-log plot everything is a straight line. But we now can measure the Hubble constant to great accuracy, and what we've been able to do is realize something else. So Einstein said this was his biggest blunder and he wanted to get rid of it. But, it's like trying to get the toothpaste back in the tube. It's impossible. Because if Einstein hadn't invented the cosmological constant, someone else would have. Because by the miracle of modern mathematics, which Frank will appreciate, you can rewrite this equation. And now this is a small step for a mathematician, but a giant leap for a physicist. Because we can all do this. We can always take this and put it over here. But what it means is when this term's over here, it represents geometry. When it's over here, it represents energy and momentum. And it represents a new type of energy in the universe. You can ask, what type of energy would produce this repulsive force? And we know what type of energy it is. It's remarkable. The energy of nothing. If you put energy in empty space, it means you get rid of all the particles, get rid of all the radiation, you got nothing there. If that nothing weighs, then it produces a gravitationally repulsive force. It's not like anything else. Now, for a long time, we all knew that nothing had no energy, because it's crazy to imagine empty space as having energy, because it would be repulsive. And because, in fact, when we tried to calculate the amount, we got it wrong by orders and orders of magnitude. Again, a whole other lecture. But what would the effect of such energy of empty space be? Well, it turns out we can measure the Hubble constant, which is velocity as a function of distance nearby, and you saw the straight line. But if we measure supernovae, which is bright, so bright we can see them at the far end of the universe, we can try and see how fast the universe is decelerating, because gravity always sucks. And that's what astronomers tried to do in 1998. And this is what they discovered. It's hard to see, but I'll try and show you. There's the Hubble curve I showed you earlier, the straight line. And then let me draw a straight line through that data set and bring this whole thing down. So there's a straight line there, and extrapolate that straight line up there. If the universe were decelerating, these distant supernovae would be measured to be here. They don't. They're measured above the straight line. It turns out, if gravity works, the only explanation of this, and if the data is correct, and again, we can have discussions about this, but it turns out all subsequent analyses show the same thing. This implies the universe is accelerating. This implies, in fact, the craziest thing in nature that we've just discovered, and we should celebrate this crazy discovery. The dominant stuff in the universe is empty space. And we should, in fact, make a great deal of ado about it, because not only is it the dominant stuff, but what is really exciting about it is not what we don't know, but what we don't know. We don't understand it at all. It's the biggest mystery in science. We don't have the slightest idea why it's there. And no one has it. You should, if anyone tells you they understand why it's there, you shouldn't believe them, whether they're Frank or a string theorist. But we think it's very exciting because we think its existence is probably tied to the very nature of space and time and the origin of our universe. And what's really interesting about it is it will determine the future of the universe. And we don't know what the future is. It will determine what our universe will do in the future. And I spent a lot of my own research time in the last few years trying to understand that. But the implication it has is particularly nice, especially for someone like me who doesn't like rules. All of the results of classical general relativity go out the window. We used to think if you lived in a closed universe, it must recollapse to form a singularity. That is, in fact, not true. Once you allow for energy like this, which violates an energy condition in general relativity, its energy is weird. It blows, it doesn't suck. Once you allow that, then a closed universe can expand forever. And if you have the right kind of energy or the wrong kind of energy, an open universe can collapse. Geometry is completely irrelevant. And until we understand the nature of this dark energy, which we don't, we won't know what universe we live in. The simplest proposal for what this dark energy is in fact a cosmological constant, the energy of the vacuum in quantum mechanics. We don't understand why it has the value it is, but that's the simplest explanation. If that's true, the universe will go on accelerating forever. In which case, by the way, we live in the worst of all possible universes for the future of life. So much for intelligent design or anything else. And I wanted to quote another famous theologian. And it will be a long time, and it won't be 50 years. Now, I want to just end. Actually, good timing, actually, I think. I was going to put this in my rebuttal, but I'm sure Frank will have another of other things. So let me just give it all at once. I want to spend 5 minutes talking about science and purpose. Because I don't want to argue, although it may seem like I'm arguing, that science argues that people of faith are wrong. And I want to use the example from cosmology that I think is important. And you know, Michael talked about this a little bit, but science is independent of questions of purpose. And the best example I can think of is Lemaitre, Georges Lemaitre, a Belgian priest, who was really the first person to realize there was a Big Bang. He realized it theoretically, because he realized that Einstein's general relativity did not allow a static universe. In fact, Einstein didn't believe it. Einstein really ridiculed him for a while, as he tended to do with people who disagreed with him, but eventually the good thing about Einstein is he came around. Lemaitre showed it had to begin, if classical general relativity, it really had to begin in a singularity. It had to begin with a Big Bang, a cosmic explosion. Now, the thing that's significant about that is up to that point, science had decided the universe was eternal and static. He showed if Einstein was right, it couldn't be. That was a profound shift, because it meant the universe had a beginning. When he came up with that result, what happened? Pope Pius, at the time, was so excited, he wrote an open letter saying, "Science has proved Genesis." Now, what did Georges Lemaitre do? Lemaitre, who's a Belgian priest, wrote to the Pope, and he said, "Stop saying that. This is a scientific theory, and it makes predictions. You can take it to validate your religious beliefs if you want. You can take it to validate Genesis. But you can equally well take it to mean there is no God and the laws of physics just describe everything. What you take from it depends upon your religious beliefs, but the theory makes predictions independent of that. The science is independent of your beliefs. And we should remember that that's what science does. It doesn't provide evidence of purpose, but it also doesn't, as I'll point out, argue against purpose. And I think scientists, in fact, should realize that the success of science does not mean it encompasses the entirety of the human intellectual experience. And some people call that science versus scientism, where you take science and turn it into philosophy and say, because there's no evidence of purpose, and I would argue there isn't, there is no purpose. That second statement is philosophy, not science. Attacking a belief in purpose or design is a philosophical stance, much as defending it. It's not a scientific one. It's outside the domain of science. And to quote, in fact, someone who we all love, Carl Sagan, in a different context, who talked about aliens this way, but it's true here. The absence of evidence is not evidence for absence. There may be no evidence for purpose in the universe, and I would argue there is none. But I guess over time I've become at least humble enough, to the extent that I am, to realize that that does not justify me as a scientist saying that because there's no evidence for purpose, that I can discern that there must be no purpose. In fact, science actually, I think, can enrich faith in a different way. It can oppose blind, unquestioning belief in nonsense. It can inform people of faith. We must not respect all religious sensibilities, especially when those sensibilities are wrong. The Earth, as I was trying to argue at the beginning of the week, is not 6,000 years old, whether you like it or not. The sun and Frank doesn't explain this, I don't think, in his book, but the sun does not, maybe you just explain the New Testament, but the sun did not stand still in the sky. Homosexuality is not an abomination. It's a naturally occurring phenomenon. Women are not chattel, as it says in the Old Testament. The Kennewick man, I've tried to offend Jews and Christians alike, and now I'm going to try and offend Native Americans. The Kennewick man was not a Nubatilla Indian. And it's stupid for us to give such nonsensical respect for ancient myths, whether they're Native American or not, so that when we make an incredible archaeological discovery, the Army Corps of Engineers had to hold it back from scientists for 4 years while we listened to nonsense from Indians who claimed it was their ancestor, when in fact it was genetically related as much to them as me. And the Bible and the Quran are actually historical documents written by human beings and have to be interpreted as such. And that, I think, should inform faith. And I want to just quote some people that Frank quoted. Moses Maimonides, who wrote, he never sued me for the fact that the subtitle of one of my books is A Guide for the Perplexed, but he wrote it about 800 years earlier. He wrote many stupid things, but one of the things he did say wasn't stupid was, the scriptures, as he said it, are absolutely true. However, if the scriptures appear to disagree with the results of scientific investigation, one should re-examine one's interpretation of the scriptures. St. Augustine, was also quoted earlier, said the Bible shouldn't be read as a scientific textbook. I like this quote of his. He said, even a non-Christian knows something about the earth and the heavens, the kind of animals, shrubs, stones, and so forth, and this knowledge he holds to as being certain from reason and experience. Now it is a disgraceful and dangerous thing for an infidel to hear a Christian, presumably giving the meaning of the Holy Scripture, talking nonsense on these topics. And we should take all means to prevent such an embarrassing situation in which people show up vast ignorance in a Christian and laughter to scorn. The Bible is not a scientific document. Science is not based on faith. And the fact that we actually don't have a theory of everything, the fact that we actually don't understand a lot about nature, is not something to be upset about, but something to be thrilled about. As Albert Einstein would say, the fairest thing we can experience is the mysterious. It's the fundamental emotion that stands at the cradle of true art and true science. Thank you. Yeah, sorry. I guess we got to get this back.
No worries.
Pour this all over myself.
Good job. Okay, Frank, 5 minutes. Or whatever. And get you right here. Very good. You don't need the slides.
No, I won't need any slides. Now, Lawrence has quoted two extraordinary physicists, Gerard Tooft and Stephen Weinberg, directly critical against me. And he and I are in agreement that they're extraordinary physicists. But it wasn't necessary to quote them because Lawrence knew the basic physics himself. It's basically an argument from authority. The difficulty is all three men, Lawrence Krauss and Gerard Tooft and Stephen Weinberg, are particle physicists and not relativists. Now, the key thing that makes my arguments make sense, but do not make sense to these gentlemen, is that they have not thought sufficiently deeply into the questions of global general relativity and how it can stabilize these particle physicist problems. Now, it's a very subtle argument mathematically, and I'm reluctant to discuss it here. I think that Lawrence and I should argue the questions on the mathematics. But the only thing I can say is that my physics is correct, but not if you put boundary conditions that particle physicists like Tooft and Weinberg and Krauss put on these equations. If you do that, necessarily you will get the results that Weinberg and Tooft talk about. But it was not necessary for Krauss to bring them in because he knows as much about the physics in this particular area as those two gentlemen do. As I say, it's a much more subtle question mathematically. What I'm interested in is following through this argument about science being experiment. Lawrence and I are totally in agreement on this. And he did a beautiful job of presenting the latest data showing the acceleration of the universe. Now, it was quite a shock to me because in my physics of immortality, of course, I was defending the idea that the universe has to recollapse. I did not expect an acceleration in the early part of the universe. I had predicted that there would be an acceleration phase in the universe by a slightly different mechanism than I developed in the physics of Christianity. But I did not expect it to occur in the early universe because I could not think of any way to cancel it out. Now, a deeper thinking about the Standard Model and how particles were actually created in the early universe and how you could arrange this by a Standard Model process is what gave me an inclination, an idea of how you could have an acceleration in the early universe and later have it being canceled out. I describe it in outline in my physics of Christianity, but in more technical detail in some of my papers published in the physics journals, which if anyone is interested in the mathematics, you can go to the papers which are also on the archive. I think that's the most convenient for everybody. Now, of course, what I'm interested in is seeing if we can get some experimental predictions out of this. In my technical paper, I give some of the predictions, and one of the things that had bothered me at the time was that the mechanism I was suggesting would indicate that the Sunyaev-Zeldovich effect, that's how roughly the cosmic microwave background radiation interacts with the free electrons in a galactic cluster. I had predicted that it should be a factor of 4 less than the standard theory predicted, but that really bothered me. Turns out that this past September, an article was published in Astrophysical Journal indicating that remarkably, if you use the latest data from WMAP, the Wilkinson device for looking at the microwave background, it indicates that in fact, looking at 31 clusters, that the Sunyaev-Zeldovich is a factor of 4 too small. Then I looked at the data in some detail in this article, and I was seeing the detail curves were following what I had actually predicted. Now, if this works, and I don't want to say this is definitely true right now because it needs more investigation of the evidence, it would indicate that these problems which Weinberg raised up about these additional terms which have to be there, the full symmetry group of general relativity has to be expressed, and the Einstein equations only get the lowest order terms. It would mean, in particular, that these other terms, which Weinberg thought would make the theory entirely unpredictable, then start to appear, higher and higher terms are starting to appear in a very nice hierarchical way, so you can still get some predictions out of the theory. Which I, of course, as a physicist, proceeded to do. Now, from this, we can see that the theory is going to be defined only if the singularity is there. Only if you have an initial singularity and a final singularity, and only if these are connected by this second person hypostasis. This is why I am still confident in the theory. And so I think that you should go through the technical articles rather than believing either myself or Lawrence Krauss, because ultimately this is going to be a technical argument which will be settled in the only way we think it should be settled, by experiment. Science rules. Okay.
Well, I don't have a lot to say. I just want to say one thing that I didn't say, and maybe that's relevant to this. So, to reiterate what I pointed out is that based on what we understand, namely based on the data, the universe is accelerating. Based on the data, therefore, if you're a betting person, you'd argue that it wouldn't recollapse. It's only required to be recollapse if you a priori decide that such a recollapse is necessary for theological reasons, I would argue, but not for scientific ones. But also, the claim that's made that somehow, the other thing that really worries me, frankly, Frank, and I know you're not this way, but I've dealt with a lot of people lately who want the universe to end in 50 years. And I think it's pretty bad for people to want that. But I think that's also fallacious in the extreme. Because the claim that somehow if we could harness baryon decay, which, by the way, the Standard Model tells us exactly, I mean, it's not a matter of technology. It's not a matter of engineering nature. Nature tells you how fast it works. You saw it. If we wait 10 to the 30 years, one proton might decay in the entire universe. But even if we could engineer that by some weird process, with, some quantum mechanical process that Frank might be talking about, which you can't because it's based on quantum mechanics, so you can't engineer your way around quantum mechanics. You use it to do the calculations. But even if we could, it'd be irrelevant, because annihilating matter would not... The remarkable thing about a universe that happens to be dominated by the energy of empty space is, once it starts being dominated by the energy of empty space, nothing you can do to matter will change that. Once it started being dominated by the energy of empty space, you can take all matter in the universe and turn it into radiation instantaneously. You can turn it into whatever you want, and it won't stop the collapse of the universe. So even if we found out a remarkable mechanism to destroy the entire universe to try and prove that God existed, it wouldn't make a difference. The energy of empty space is dominant now, and unless that energy of empty space goes away, the universe will go on expanding forever. Now it may go away. But since we don't understand that energy of empty space, we have no knowledge of what it will do or what it won't do. But nothing we do to us, the stars, and everything else in the universe makes a hill of beans difference. The universe is going to do what it's going to do anyway. And I wish more people would just realize the universe is the way it is, whether we like it or not.
Because of the tech problems, we have just the one mic, so why don't you guys just stand here and swap back and forth. I'll call out your questions. Just keep it short. Direct who you'd like to ask it to, say Lawrence or Frank or both or either. and then they can handle it from there. From the back, go ahead.
Frank, in your physics, where's the afterlife?
I'm sorry, I couldn't hear you.
Where's the afterlife?
In your physics, where's the afterlife?
I developed that in more detail in my book, The Physics of Immortality. What I am proposing in that is that we are all brought back into existence in the far future as computer emulations. That is possible technically if we have an unlimited increase of computer capacity. As we would have is the universe collapses into itself. Now, Lawrence and I are in complete agreement that it's all over for life if the universe were to accelerate forever. There is no dispute on that technical conclusion. Now, where we differ is I have claimed a mechanism that will, what he says with regard to the acceleration, if the acceleration is due to a cosmological constant, and there is nothing else but that naked cosmological constant, he is correct in saying that the universe will continue to accelerate forever, and what happens to matter will make no difference. He is absolutely correct there. I am proposing an alternative mechanism that will turn the acceleration off, effectively by canceling the cosmological constant. But I think that we have a chance of surviving. I think that it's not just, however, a hopeful wish, as Lawrence would have it, but I think that the physics is actually forcing this conclusion on us. I think that in order to, I think that Stephen Hawking got these calculations correct when he originally proposed that if a black hole were to evaporate to conclusion, it would violate unitarity. Now, we're both in agreement that unitarity is a fundamental physical law and cannot be violated. It's absolutely central to quantum mechanics. We can dispute whether Hawking got the calculations correct, but we relativists, including the relativists here at Caltech, went through Steve's calculations in some detail, and we are confident that he basically got it right. So what I was proposing is that we can eliminate this possibility of a black hole evaporation by having the universe collapse on itself and end in finite time. You can prove, however, that if the universe were to expand indefinitely or accelerate indefinitely, black holes would, we've seen them out there, they would form, they have formed, and they would violate unitarity because they would evaporate to completion. This is the argument I give why we have to expect the universe ultimately to collapse in on itself.
Lawrence, do you want to respond?
Well, just a little bit. I won't respond about the afterlife, but the unitarity is important in physics, not because of quantum mechanics. It basically says that probability is conserved, that the sum of all events that must happen adds up to 1. The probability of all those things adds up to 1, and it would be really weird if it didn't, because that means events that couldn't happen would happen. But the problem, I think Frank really demonstrated one of the problems that I have with his argument, which is that you make this statement, well, you can't have black holes can't exist because if they evaporated by a Hawking mechanism, they'd violate unitarity maybe, and therefore we have to invent some mechanism for the whole universe to avoid that. Well, first of all, we don't know, and as you know, even Stephen now disagrees with himself. We don't know if in fact, most physicists would say black holes don't violate unitarity. We just don't understand the physics well enough. We just haven't figured it out. So we don't know the answer. So when we don't know something, it's really bad, it seems to me, to say, well, therefore the universe must work this way because I think I know the answer. But beyond that, Frank also pointed out, black holes do exist, as far as we can tell, in the centers of galaxies. And they have been created. And for all we don't know, there may have been a spectrum created, in which case some black holes may have already, God forbid, literally, evaporated. And if they've already evaporated, the whole universe doesn't need to collapse anymore to save us, because it's already been violated.
All right, let's, over here, yes, right there.
Frank, with regards to the virgin birth mentioned, or you mentioned double X male.
Yes?
Did you mean double XY male?
No.
Microphone. Repeat the...
Okay, the question was, when I said double X male, did I mean double XY male? No. Double XY males are abnormal in many different ways, whereas double X males are not even aware of their nature until they are having a DNA test made. And so they are much more close to normal males. And they do not suffer from the abnormalities of double XY males.
And they have no Y chromosome?
That's correct, they do not. Because we have to remember that we are a descendant from reptiles, 200 million, 300 million years ago? And reptiles do not have sex chromosomes. It's only the warm-blooded animals like birds, which use a WZ chromosome sex determination system.
And they don't like sports.
Maybe I'm going into too much technical detail.
Well, no,
I got you.
Let me. One thing I learned from you, I was reading when I read your book about, I'm not a biologist, but is that you also do require an improbable event on top of that, right? You require
yes.
Jesus not only to be an XX male,
yes.
but to be on the extreme far end of the
yes.
tail,
Improbable.
because otherwise you'd have very small genitalia, high voice, etc.
Yes,
Yeah,
exactly. Yes, yes, definitely.
Born by virgin birth or not?
Why should we care whether it was a virgin birth or not?
What I was concerned in the book is primarily to show that the central assertions of Christianity make sense from the scientific point of view. Now, in the questions of the virgin birth, the reason theologically is, first of all, you wanted to say that Jesus has no biological father. But also, what you also want to have is Jesus without original sin, because if he has original sin, then you have the entire Christian theory of the atonement, the sacrifice of someone who is with a lamb without blemish, is the term Paul used, will not go through. So what I show in my book is that in the events leading up to the virgin birth, you also have a mechanism that can cause the elimination of this, what I'll term original sin, because it makes us want to, we have a genetic code, I'm arguing, in us that makes us want to commit evil against our fellow, and that can be deleted. And it works best, most efficiently, if you have a virgin birth.
Right here.
Yeah, in this paradigm, where does Satan and hell come in?
The model we have to agree, of course, in Christianity, although there have been no church councils on the nature of Satan, obviously has to exist, because if Christianity is correct, because we have Jesus casting out devils, and he has one central master, Satan, we are told by Jesus. What I am proposing in this, that Satan should be thought of as a genetic code, a DNA sequence, which is throughout the entire metazoan order, not just in animals, but also in plants, which came into the existence, at least 500 million years ago. So the point is, this particular DNA sequence would be deleted, eliminated or replaced in Jesus and also in Mary's DNA.
I think Jerry Falwell said something like that.
Can I just add one? I mean, I think most of the questions will be for Frank, so I'll just jump in every now and then. So I guess I'll take my scientist hat off. I wanted to respond to the last one. So I think, if I'm looking and asking for plausible hypotheses, to me it's equally plausible regarding the virgin birth to the statement made, in fact, by Hitchens in his new book, God is Not Great, which is to note that pretty well every religion has had virgin births. It's gone back well before Christianity, which of course probably borrowed it from another religion. And in fact, therefore, I would suspect that that it's equally likely that there had to be a virgin birth in the Christianities, is because it in fact was derivative from other earlier religious practices from other religious groups, which I think is an equally plausible explanation of what is an equally implausible event. And Hitchens says it better than I do, but I'll say it anyway. You know what he said? That the religions seem to like the idea that the birth canal is a one-way street.
Let's go. Yep.
It's for Tipler. It seems like your argument basically summed as the facts of physics lead you to conclude that Christianity is true. My question is, before you were aware of these facts, were you a Christian? And if so, why?
No, I was not a Christian. The history of my religious experience, you could probably tell from my accent that I grew up in the South. And my religious training, early religious training, was that of a Southern Baptist. And I was converted, much like Michael, a converted evangelical early in my life. I became, however, an agnostic, like Lawrence now is, at the age of 16, because I did not think that the evidence for the existence of God was sufficiently strong. And I think, like I think hopefully everybody in this room, is committed to rationality, that you want evidence for your beliefs. But when I became a postdoc at the University of California, Berkeley, in general relativity, I started working with John Barrow on this book, The Anthropic Cosmological Principle. We were aware of this fascinating paper by Freeman Dyson about whether or not life can go on forever in an open universe. And I was wondering if the same strategy could be played in a closed universe. And I realized it could be played only in a closed universe if and only if the final singularity were a very special type, a single point, an omega point in the Penrose construction, sea boundary construction. So I said, aha, a single point at the end of time. I call it an omega point. But Teilhard de Chardin had this idea that God was an omega point. So maybe there's a connection between science and religion here. Before that, I thought there was no connection between science and religion. So I started to investigate this possible relationship in more detail. As I explicitly say in my book, The Physics of Immortality, in which I developed this omega point theory. I was not a Christian. I have a section entitled precisely that. But one of the things I had missed, it's in the book, The Physics of Immortality, but I did not notice it, namely that God, the singularity, was in fact triune. There was an initial singularity, there was a final singularity, and there was a connection singularity. It was in my equations and it was in my drawings. So, aha, God has to be 3. And I said, that suggests Christianity, so I started investigating more in detail into the notion of Christianity. So I've always been strongly influenced by the Christian theologian of Wolfhart Pannenberg, who made suggestions about how Christianity actually physically works, how we should think about Christianity, and that led me to compare the physics with the actual theology, and I think it helped me develop the physics in much more detail.
So now you're a relapsed agnostic.
Yes, exactly. But I think that I'm being forced by the physics. Lawrence will tell me I'm just gone crazy.
I'll tell you that in private, Frank. But I do want to actually provide substantiation for at least one thing you said, so I don't appear to be too mean-spirited. I do think that, in fact, one of the things I'm proud of recently is that we've actually, as you know, done a lot of work on the future of life in the eternally expanding universe. And in fact, I think Freeman Dyson's argument about life existing forever in an open universe is not true. So I would say that, in fact, probably the only hope for eternal life would be a collapsing universe of the type that Frank said, because at least near the singularity, all bets are off, and you can't disprove the possibility of eternal life. But I would say that you would be driven, if you believed in the necessity of eternal life, I do agree, by general principles to probably a collapsing universe. There, I agreed with you about something.
Go ahead.
If Jesus is God incarnate, how could he get things wrong? Because he specifically says in the Gospel of Matthew to his disciples, if they persecute you in one town, flee to the next, but you will not have fled to all the towns of Israel before the Son of Man returns. And he also says in the Gospel of Mark, at the end of Mark 8, beginning of Mark 9, there are some standing here today who will not taste death before they see the Son coming in the power of his Father with the holy angels. And in John, he says there that the time is coming and is now here, when the dead will step forth in their tombs at the sound of the voice of the Son of Man and face judgment. So he seemed to believe that the world would end in his generation. How does that square with him being God and with your prediction of the end of the world in the next 50 years?
Needless to say, this question you have raised here today has been raised periodically in Christianity over the past 2,000 years. No new physics is required to pose this. And all I can do is say that the model of the incarnation I develop in my book is consistent with at least one of the answers given by the Christian theologians over at least the past 1,000 years. That remember what Christianity asserts, that God has deigned to give up his immortality, to come into the world as a human being. To fully be a human being, you have to also be ignorant. If you retain your full divinity, if you retain your omniscience, then you cannot be fully human. There is also a passage in Matthew justifying that, talking about the second coming, in which no one, not the angels, not even the Son, knows the hour and day of the return. So this has been interpreted as precisely what I have just said, namely that Jesus has given up his omniscience, and he himself, as a consequence of this, does not know when the second coming will occur.
Let's go on this side of the room, standing back against the curtain.
Yes, earlier you said that Jesus was born without original sin, and if that's true, then how can he claim to be man, since one of the fundamental aspects of our nature is the internal struggle of good and evil?
Because Christianity does not fully claim that he is man. He is man, but without original sin. That he is a lamb without blemish, which was Paul's term. Whereas all of us, except Mary, except Jesus, and in the Catholic tradition also Mary.
Mary has to be in the Catholic too. I was going to add that.
Okay. These two would be without original sin, and hence not human in that very limited sense. They are without the influence of original sin. It does not have to be eliminated from them.
Let's go back over here, yes, sir, in the green shirt.
I have two questions about the virgin birth. One, why would you bring up the Shroud of Turin if it's been carbon dated to not be old enough for Jesus' time? It was carbon dated in the Middle Ages. So why would you bring that up as an argument? And the second part is, you said that certain animals have been proven to have virgin births with the XX chromosomes. What are examples of these animals, and are any of them mammals?
The question is on back to the virgin birth. Everybody's favorite subject. And parthenogenesis, can this actually happen naturally? Does it happen in mammals? Are there examples from the natural world where this is explained?
That was the second. The first question was why the Shroud of Turin?
The Shroud of Turin. As we are all aware, the Shroud of Turin was dated by 3 carbon-dated laboratories across the world, and got all of them a medieval date, roughly 1300s, 1400s, somewhere in there. I don't remember the exact. I give the numbers in the book. Now, this was quite a shock to people who had done historical work on the Shroud, because it looked like from the historical evidence that it was genuine, completely consistent with 2,000 years. Now, there are 2 reasons for being a little suspicious of that number. Now, we have to be careful, because until another experiment is done taking into account these claims of error, we will not know. But the general opinion now amongst people who studied the Shroud in depth, and who also think it was genuine based on the historical evidence, think that the main problem was that the samples were not taken randomly over the Shroud, particularly in the deeper areas near where it would have to be it would have to be real if it were a genuine object, i.e. near the images and near the blood stains. It was taken from an area far out, which there is good reason to believe it was a medieval repair. So what you're seeing is the medieval repair. Well, it says it's medieval. What do you expect? Another argument has been given that at the time the carbon tests were actually carried out, that linen, which is what the Shroud is, has an unfortunate tendency to accumulate later bacterial contamination. And in fact, it was shown, and one of the leading experts in the radioactive dating, who developed this really new technique that does not require large samples, was one of the co-authors on this in the paper in Review of Scientific Instruments, which indicated that you could get for shrouds used to wrap mummies, that the dates that they got were much younger than you actually knew from historical evidence when these things were laid down. And it was established that the numbers you would get would be correct if you first go through a more complicated chemical procedure to remove any possible bacterial contamination. Now that has not been done. Redoing the experiment on the shroud to eliminate all this bacterial possible contamination has not been done. So I would say that the implications of these two objections is we'll have to get a much better understanding of the possible sources of error on this particular type of object. A linen shroud, we've got plenty of examples from the Egyptian mummy, so we can experiment on it. And once we are convinced, once we get a very reproducible data consistent with the historical data on the mummies, we should redo the experiment. Until
I think to be fair to the other questioners, since you already dealt
Yes.
with virgin birth, let's just go on to the next question. But Lawrence wants to give.
Yeah, I might as well say something right now. Your explanation points out something that did concern me related to the questioner. If one is generous to your explanation, which is that the Shroud of Turin is at best controversial rather than being definitively a fraud, but at best controversial, you'd agree? Yeah, then I couldn't understand why one would choose that as as a significant part of a book describing the physics of Christianity. To pick something, I mean, the only methodological something that would concern me about your methodology is, in that particular case, was, well, I think you thought you could explain it with neutrino-antineutrino pairs, and so therefore you chose that piece of data because you thought it agreed with what you said. And in fact, I don't think it's fair to choose something which is at best controversial and many experts think is probably wrong. At this point, if it's controversial, just don't worry about it. There are lots of other miracles you can try and explain, but I didn't think it was appropriate to include that in the book, I should just say.
Let's go right here.
Dr. Krauss, you talked about how science doesn't speak to religions in a way, and then you said that the evidence for a continually expanding universe is the worst possible scenario for all of life.
For future life.
For future life. And then you just kind of sarcastically threw in there so much for intelligent design, which sounds like a very philosophical statement rather than a scientific statement, because you're using science and an ever-expanding universe to a God's intelligence and say it's not really intelligent if it doesn't know how to sustain future life.
Well, you're right. I was being flippant. I guess I feel kind of it's important to do that every now and then because of the distortions about what intelligent design has been claimed to be. The notion that life, it is the worst misrepresentation of biology to suggest that there's evidence in biology for intelligent design. The arguments for that are multiple, but one of them is, in fact, not only is the argument I gave that the universe itself, life won't survive in the universe if it behaves the way it is now, but even earlier than that, 99% of all species that have ever been on Earth are extinct. Now, so you can either argue that God designed things so that they wouldn't survive, or alien. Remember, the intelligent design people don't say it's God. It could be aliens. They don't say who designed the aliens, but that's another question. But so you're right. It was an impertinent philosophical thing to say that a God that would design life to be intelligent would design it to survive. It could have been part of God's grand design that most species on Earth would not survive, and I have no right to presume one way or another about what the divine creator's purpose was, and I was being flippant in saying that.
Can I make a respond, Michael?
Well, let's give these guys a shot here.
Yeah, very briefly for both gentlemen. Well, first, Dr. Tipler, if I've understood your arguments correctly, you put a lot of effort into the mathematics, in particular, general relativity and quantum mechanics.
based on the notion that that the laws of physics must be consistent for all time, all past time and all future time. First of all, for both of you gentlemen, would you agree with that? Would you agree that the laws of physics must be consistent for all time? And if so, why? That's really my question. What's the motivator for saying that, yeah, we've seen the laws of physics been consistent back to the first 3 minutes. Why would we believe that they were consistent in the first 3 minutes? Why would we believe they have to be consistent for the rest of time?
I think you've answered your own question. What you do in testing the laws of physics and their range of validity is push them to more extreme conditions. Now, one of the mysteries of cosmology is why, when Alpha and Herman predicted the background radiation, they predicted it to have roughly a temperature of 5 degrees. They published this in the leading science journal of the world, Nature, in 1948. But no one looked for it. Now, Weinberg has a chapter in his book, The First 3 Minutes, addressing this question. We had the technology to look for it right then, and it's a tremendous breakthrough. Lawrence and I are in total agreement, one of the great discoveries of cosmology in the 20th century. So, if it was so easy to do and so important, why didn't anyone look for it? Now, Weinberg, I think, gets the correct answer, namely that if the equations of physics predict something that's so absolutely counterintuitive, it's hard to believe that this stuff is really real. It's easier to think that the laws of physics simply didn't apply on the cosmological scales or earlier in human experience. This, in fact, was the motivation of the creators of the steady state theory. They were saying on a sufficiently large time, the laws of physics simply won't apply. And I remember that people were objecting to the second law of thermodynamics on the same basis. But the second law comes in crucially in getting the temperature in this calculation. So we are now know by observation that the laws of physics apply to the very early universe. This gives us confidence that it will apply in all circumstances.
Frank,
Yeah.
will you let Larry take a shot there?
Yeah, I think that's a really deep question and an important one. And in fact, we are a remarkable revolution took place in physics in the last 40 years about understanding the nature of scientific truth. We used to think some theories applied over all scales for all times, and we now know that just doesn't work. Newton's law of gravity doesn't apply on all scales. When you get to moving very fast, you have to replace it by general relativity. Classical mechanics doesn't apply on small scales. Quantum mechanical processes go on. And in fact, there are, and I won't, there's no time here, nor would it be clear to most of you, but there are dozens, if not hundreds of reasons to know, I shouldn't say that wrong, to highly suspect that the laws of physics break down at different, as we understand them, break down at different scales. All that means is that we'll have to understand new physics. That's why people like me do physics, because we hope the laws break down so we can discover new ones and get famous. Okay? And so the Standard Model has so many. If you push it up to arbitrarily high energies, it's a particle physics argument, not a general relativistic one, it produces nonsense. Now, we expect that, in fact, one of the reasons it produces nonsense is because it's not appropriate to describe physics at all scales. Even the best theory we have in nature, Richard Feynman used to be here, quantum electrodynamics, we know predicts nonsense at a certain scale. It can't be applicable over all scales in nature. It will predict nonsense. It doesn't bother us. We know it'll be supplanted by another theory. That's why we're spending billions of dollars with an accelerator that's going to come online next year in Geneva. And so we fully expect that the laws of physics change over scale. And that's happened. That continues to happen. And to make the presumption that that won't be the case flies in the face of everything I know about particle physics.
Let's go back to the back of the room there. Yes, sir.
What's going to happen to the billions and billions of people that worship the wrong God?
A physics question.
It seems to be indeed I'm being thrown a large number of theological questions which are entirely, I think, already answered.
Inquiring minds want to know.
I'm not sure I can answer on the top of my head, but it depends on what is meant by the wrong religion, and how far off you are, and whether or not you're willing to make adjustments when you're brought back into existence, when you're resurrected.
I think what he wants to ask is, let's say you're Hindu and you believe in Ganesha, and you don't believe in Jesus. What happens? In your opinion.
I have to call your attention to the fact, Michael, I'm not Jesus, I'm not God.
That's probably the right answer.
I am. No, I just.
Excellent, you answer it. He's more closely related, anyway.
Dr. Tipler, if the physics of Christianity, if your book is correct, then God is no longer supernatural, but just natural, and all of the mysteries of God become questions like, what is the rate of supernova? They have interesting answers, but they no longer have the same impact.
I think you're misreading the Christian tradition. The Christian tradition is that you can always justify the central positions of faith on rational grounds. And also, I disagree with your interpretation that the singularity is natural. You are predicting its existence through natural law. You are not, however, saying it is subject to natural law. Anything in nature is subject to natural law, but the singularity is not subject to natural law. That, in fact, was one of the central objections which Fred Hoyle had against the Big Bang Theory, because it is predicting the existence of something that is beyond not only known physical law, but is outside of all possible physical law. And I want to make one addition. When I was taking a course in general relativity from Steve Weinberg when I was an undergraduate at MIT, he was addressing in a much more definite term why he did not believe the Big Bang Theory. And he said because the Big Bang Theory resembles too closely the account in Genesis. So what he was letting, unfortunately, his preconceived religious beliefs or anti-religious beliefs dictate his physics, which is a big mistake. But Christianity necessarily deals with the real world. Christianity asserts that Jesus really did, as a matter of fact, rise from the dead. And in principle, that can be established one way or the other. If it were established that he did not rise from the dead, then Christianity is simply false. End of discussion. Christianity has always made assertions about physical reality and always will.
Okay, we're going to take those.
We'll
take one more question, but to our people in the side room there, afterwards, do feel free to come out and meet the speakers and get their books signed and so forth. Let's try. All these guys raising their hand. Well, okay, I'm trying to be fair here. Yes, sir, go ahead.
I'm curious, we're talking a lot about physics, like a yes, no, or maybe what both of your opinions are about string theory.
Wow, maybe we don't want to get into that.
I think I'd like to.
Okay, go for it. Yeah.
No, go ahead, Frank.
Well, Lawrence knows what I think of string theory since I have expressed it in my book. I think it's a complete waste of time. I think it's been very misleading to the scientific community. And I wish that Lawrence had been quoted correctly by the New York Times, in which he said, was quoted as having said that string theory was completely unfruitful. I think that that is saying the least of it. I think that we already have a nice theory of everything. We don't have to invoke a string theory.
I've since rescinded my statement about it being completely unfruitful, because John Schwartz, who's here at Caltech, after he read that statement by me in the New York Times, sent me a basket of fruit. I actually think that string theory has thus far been impotent in coming up with any great significant successes. However, I don't think it's a waste of time, actually. I think it's worthwhile for some people working on it. I just don't think it's been very productive. And physicists will move away from some things that haven't been very productive. It is, whether one likes it or not, it is science, and therefore I think distinct from some of the things that we've heard.
I think we'll take one more. Yes.
This question was already asked, but I don't think there was an answer. Could you name some of the non-primate animals that have two X chromosomes?
The question is, name some animals that have two X chromosomes.
Or that parthenogenesis, that virgin birth.
Yeah.
Are there any mammals? It was an interesting question.
Okay. The answer is that we have never seen any mammals which have a virgin birth. In particular, we've never seen any primates. Now, the question is it just rarer than it is in other vertebrates? We've seen it, for example, in birds. We've seen it, for example, in reptiles. There are huge numbers of examples of each. We simply do not know whether it can even occur in mammals, which is why I would love to see some more experiments done, which is why I was raising the point that it's very easy to do an experiment now. Because amongst mammals, we have 6 billion mammals in the species Homo sapiens, and that's a huge database upon which to do experiments.
Please help thank Frank and Lawrence.
Thank you, Lawrence.
Good job, guys. Nice job. Good job. Thank you so much. Yeah.